Okay, good morning, everyone. I hope you guys are doing really well. I am going to go over numbers 22 through 33 today with you. Um, so let's get started. If you are looking at the first problem, number 22, you can see that it is a quotient, and we have stuff on the numerator, stuff on the denominator. We always want to look at the numerator and denominator separately first, though. So just looking at the numerator, if you just get rid of that stuff, you have a negative 21, w to the fifth, x squared. Now, there's nothing we can do to that, so that's good. We always want to double check that first. Now let's just look at the denominator. Looking at the denominator, we have 7 w to the fourth, x to the fifth. Again, there's nothing to do there. So now is whenever we want to go back and look at this as a whole. Concentrate, focus in on the whole numbers there. We have negative 21 divided by 7. That is going to turn into negative 3. And then we have w to the fifth on top, w to the fourth on the bottom. Because it's division, we're going to subtract. 5 minus 4 is 1, so it becomes w to the first power. And then we have x squared on the top and x to the fifth on the bottom. 2 minus 5 is negative 3. Now, moving forward, we cannot leave that with a negative 3 exponent. Therefore, the x to the negative 3 needs to go to the bottom. Don't get confused with this negative 3 right here. That's just a negative 3. It doesn't matter. It's not going to move. The only time it moves is when the exponent is negative, not the base number. So we have negative 3, and then w on the numerator, and on the bottom, we have x to the third. And that's it. The next one, I'm not particularly a fan of, but you can see that I just circled it, that giant dot right there. That just means multiplication. So it's actually multiplication all the way across the whole problem. And so I'm going to reorganize this to make it a little bit easier to see what's going on. So we have an 8, and then we have a negative 6, and then we have an m to the fourth. We have an n to the third, and then we have another n to the fifth, and then we have a p to the negative 1. All right, so now we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I just counted all of the terms that I have here, and then I counted all the terms that I have up here just to double check that I had written all of them and I didn't miss any. So we want to go ahead and multiply 8 times negative 36. I'm sorry, 8 times negative 6 is negative 48. And then since there's only one m, we're just going to write m to the fourth. And then we have two n's. These are multiplying. So in order to, when you multiply the bases, the powers add. So that becomes to the eighth. And then the p, as you can see, it's to the negative 1. So we're actually not going to leave it up top. It's going to go down to the bottom, and it's going to become p to the first. And that is actually the final answer to that problem. Negative 48, m to the fourth, n to the eighth divided by p to the first. All right, looking at number 24. This one is really easy. This is probably the easiest one on the whole page because as you can see, all of this is taken to the zero power. And so anything to the zero power is simply 1. All right, so let me scroll down here for a second. And let's look at number 25. 25, you can see we want to look inside first to make sure there's no like terms or anything that need to be combined. There's a negative 5, there's an r to the fifth, s to the fourth, and t. So there's nothing in there to do. So that's good. Now we're going to take this 4 right there, and that is going to get distributed to everything. Keep in mind this little t right there, it's t to the first. So we have, don't forget, and also it's really easy to forget to take that first negative 5 and forget that it has to also go to the fourth power. And then we have r. Now notice it's r to the fifth and then to the fourth. So we have a power to a power. Anytime that happens, they multiply. 5 times 4 becomes 20. And then we have s to the fourth, which is s to the 16th, because 4 times 4 is 16. And then we have t to the fourth. And you might say, what about that negative 5? Should it go down to the bottom? Don't let that trick you. The only time something moves to the bottom is when the exponent is negative, not the base number. Okay, number 26. Looking at the numerator, anytime we have fractions, remember what we do. We're going to get rid of the bottom stuff for a second. Just look at the numerator. Is there anything to simplify in the numerator? That answer is no. Now we want to get rid of the top. Just look at the bottom. Anything to simplify there? There isn't. So now we can go ahead and look at both things. And you notice right away there's no number out here that we need to divide, but there are two m's. Now, anytime we're dividing, we're going to subtract their powers. So what we have, and I'm going to do a little scratch work off to the side. Actually, I'm going to do it down below. But we end up with 8 minus negative 8. And that actually becomes 8 plus 8, which is 16. So these right here, these two, are going to turn into m to the 16th power, because it's 8 minus negative 8. Now the p's, they become p to the 2 minus 2, which is 0. But as we just had a couple problems ago, anything to the 0 power is 1, so we don't need that there. So our final answer is just m to the 16th power. Number 27, it's all multiplication across there, so that makes it fairly easy to see what's going on. Nothing to combine, although we see we have a z to the 0 power. Anytime we have anything to the 0 power, we can cancel that out. It just becomes 1. Also notice the x and the y both have negative powers, so they need to go down to the bottom of the fraction. The w is still positive, so we're going to leave that as w squared. And on the bottom, we're going to have x to the third, y to the fourth. All right, let me scroll down some more here. Give me 1 second. Now, number 28, there's a little bit of stuff going on there. The first thing, again, we're going to look, just forget about the bottom. Anything to do in the top, there isn't. There's no simplification. Then just look at the bottom separately. And this one actually has a little bit of simplification to do. You can see that there's an a to the 0 power there. That a to the 0 power can be crossed out. That just turns into 1. So the first thing we're going to do is we're going to rewrite this as 4ab over 5b to the negative 1. All right, the next thing, 5 and 4, or sorry, 4 and 5, they don't divide, so we're going to leave them that way whenever we go to write our new fraction. We have a 4 up here, we have a 5 on the bottom. The a on the bottom disappeared because it just turned into 1. So there's only an a on top, so we leave that there. Now this b up here, if you look right there, that b is actually b to the first power. And so what we end up with is we have 1 minus and then negative 1. So I'm going to do this off to the side. We have 1, move this over just a little bit so you can see it. 1 minus, and then we have negative 1. Because remember, it's 1 on the top minus the bottom, which is negative 1. Minus negative becomes plus, so both of these become a plus, so this actually becomes 2. So what we end up with on top is b to the second. And that's your final answer, 4ab squared over 5. Now, number 29 is a little tricky just because there's a lot of power to a power to a power kind of stuff. Just think of PEMDAS. PEMDAS starts with a P, it means parentheses. We want to go inside and look, you have 2 squared, and then you have this squared is to the 4th power. So let's go ahead and multiply those first. So anytime we have a power, we multiply. So you have 2 to the 8th power. And then outside of that, you still have your 3. Once again, it's a power to a power. So those two are going to multiply, and you're going to be left with 2 to the 24th power. All right, number 30, if you look at, again, we're to a fraction. So if you look at the numerator, nothing to simplify. Look at the denominator. There's still nothing to simplify. Okay, now we're going to look at what we have. We have an r to the third on top and an r to the third on the bottom. So anytime you have the exact same thing on the top and the bottom, you can actually cancel those out. So those r's to the third go away. They actually turn into 1. R to the third divided by r to the third is 1 because anything divided by itself is 1. So we're just left with t squared on top and t to the fourth on the bottom. So anytime we have division, that is going to be t to the 2 minus 4. 2 minus 4 is negative 2. And that, remember, we can't leave exponents negative, so we have to make it 1 over t to the second. And there's your final answer. All right, guys, we're in the home stretch. We have 3 more to go here. So let's look at number 31. 31 is a fraction, and as we have done for all the other fractions, we want to look at the numerator first. And there's nothing to simplify in the numerator, so that's good. Now let's look at the denominator, and there's still nothing to simplify there. Okay, now we can look at it as a whole. Look at your whole numbers first. We have 45 divided by negative 5, and that's going to be, I am going to leave this as a fraction yet. It's going to be negative 9. That negative 9 stays on top. And now, oops, I need to back up here, get rid of that. Okay, negative 9. Now we have a to the first on top and a to the fourth on the bottom. So we have to do 1 minus 4, which is negative 3. So that becomes a to the negative 3. And then we have b to the negative 3 on top, b to the negative 2 on the bottom. That one might be a little bit harder to understand, so we have, I'm going to do it off to the left here, negative 3 minus, and then negative 2. You can see the minus negatives become plus, so we have negative 3 plus 2, which is negative 1. So we have b to the negative 1. Now a little bit of cleanup work to do. We cannot leave anything with a negative exponent. So now this is where our fraction's going to come into play. The negative 9 stays put. It does not go down because it's not, the power is not negative. But then the a to the third goes to the bottom, and the b to the first goes down to the bottom. And so you're left with negative 9 over a to the third, b to the first. Now, number 32, there's some things going on here, and my recommendation would be to work inside the parentheses first before we distribute that 2. Because if you simplify the stuff that's going on inside the parentheses first, then you'll have less things to distribute that outside 2 to. So you can see 3 and 7 do not divide, so we're going to leave those alone. We're going to have a 3 on the top and then a 7 on the bottom. We have an n on the top and no n anywhere on the bottom, so we're going to leave it as n. The p's uh, are going to, I just realized that is actually not going to simplify at all. So let me back up. Sorry about that. And we're just going to have to, this is a p on top and a q on the bottom, so there's nothing that's going to simplify. So we're just go ahead and distribute that 2 to everything. So we're going to have 3 squared on the top, then we're going to have n squared. Don't forget to distribute the 2 to the 3. And then p to the third to the second, these two right here are going to multiply, which is going to give me p to the sixth power. Now on the bottom, this too also has to distribute to everything on the bottom. So it does become 7 squared on the bottom, and then q to the fourth as they multiply. Now you can leave it like that, or if you would rather actually multiply it out, 3 squared is 9. So it becomes 9 n squared p to the sixth. And then on the bottom, 7 times 7 is 49, q to the fourth. So either one of those are fine if you left them like that. Either one's great. All right, last one. This one is multiplication all the way across. And when we get ones like this where everything's all kind of mixed up and jumbled up, I like to make this a little bit easier to understand what's going on by reordering the terms so we can see what the like terms are. Before you reorder, though, you can see there's a cube right here and a square right here. those need to be distributed to their respective parentheses before you can reorder. So this is actually going to become 4 to the third, a to the sixth, remember they multiply 2 times 3, and then b to the third. Then we have negative 6 to the second, and then we have a, you can see it's a to the fifth, and then the 5 is being squared, so that actually becomes 10. Sorry, this 5 is not being squared. They're multiplying because it's a power to a power. So 5 times 2 is 10. And then you have b to the 16th because 8 times 2 is 16. All right, now we can begin. I'm actually going to try something a little different here. I am going to underline the like terms. So if we look at this 4 to the third and then negative 6 squared, that's a like term. I'm going to underline the A's. That's a like term with that one. And then I'm going to underline, oh, let's see here, we'll go with green. The B's, which gives me this and this. So what you can see, the color coding is going to help us understand which numbers are getting multiplied together. So we have 4 to the third. You don't need to multiply those out. You can just leave it as 4 to the third. And then we have negative 6. And by the way, yes, you need to have parentheses around the negative 6. If not, it would look like 4 to the third minus 6 squared. So you do need those parentheses around the negative 6. And then we're going to combine the a's. So if you look under on top of the red marking, you have a to the 6th and a to the 10th, which gives me a to the 16th. And then if you look above the green markings, you have b to the third and b to the 16th, which gives me b to the 19th. Remember, we're adding those because they're multiplying. And there's your final answer. All right, guys, you did it. We're all the way through the homework, not homework, I'm sorry, the practice problems, which were 22 through 33. Hope you guys are doing well, and I'll talk to you soon. Take care.